A little technical glitch there. So again, back to this question: how do I know 216 is divisible by 6? So if you have the sum of the digits, which are 2 plus 1 plus 6, which is 9. 9 is a number divisible by 3, and it could also be divisible by 6 if the actual number is even, which it is, because I see 6 here is even. It's an even number, so it's an even number, and it's also divisible by 3 because this 9 is divisible by 3. So that's the rule behind making sure a number is divisible by 6. It must be divisible by 3, the sum of the digits, and it must be even. Okay. All right, so let's move on. So 0 exponent. So what's happening here? 2 to the power 4 divided by 2 to the power 4. Well, that's just 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2. All of them cancel out, and guess what? You get 1. Okay? 2 divided by 2 is 1. Same thing, 3 squared divided by 3 squared, so 3 times 3 over 3 times 3. They cancel out. You get 1. Excuse me. Ooh. Okay. So what does that mean? Well, no matter what you have, remember this is the division of exponents, so you just subtract the exponents. So 2 to the power of 4 minus 4 is just 2 to the power of 0, right? And if you know it's going to be 1, well, any number raised to the exponent of 0 will just give you 1. Same here. So 3 to the power of 2 minus 2 is just 3 to the power of 0. Any number raised to the exponent of 0 is 1. So the rule is any 0 exponent is for a power results in a 1. Okay, so any number you can say x to the power of 0 is always equal to 1. So same here. So with all these examples, 4 to the power of 0 is 1. Remember, there's no brackets, so there's no brackets, so 5 to the power of 0 is 1, but you have to put the negative in front. So negative 1. If you have this entire complicated expression, so look at what you have inside here. 5 cubed to the power of 4 times 2 cubed to the power of 2, everything to the power of 11, but in the end, everything is raised to the power of 0. So no matter what you have inside, you're still going to get a 1. Negative 8 to the power of 0, so negative 8's in brackets, you're going to get 1. Even a variable raised to the power of 0, you're going to get 1. No matter what, if it's raised to the power of 0, it's 1. Okay, so let's look at some mixing up the questions here. So if I have 2 to the power of 4 times 8 to the power of 6, what can I do here? I have different bases. Pause the video for a moment, see if you can challenge yourself. How would you do this kind of a problem? Okay, so if you may have thought about it, you could have thought about, okay, if we have different bases, is there a way to make the bases the same? Well, in fact, there is. Look at number 8 for a moment. Is there a way to write 8 in terms of 2? So, you have 2 here, and I have 8 here. If I could write 8 in terms of 2, then I can have the same base. Well, it turns out that, yeah, you can. You can say that 8 is equal to 2 times 2, which is 4, times 2, which is 8. 2 to the power of 3. Okay, so I'm going to write 2 to the power of 3 here. So this is going to equal 2 to the power of 4 times 2 to the power of 3. And don't forget, this exponent still exists, so I have to put that 6 up there. But I've just now rewritten the question with the same base. And you introduce another little bit of a step here, so you have to do the power law. So 3 times 6 is 18. So I'm going to write here 2 to the power of 4 times 2 to the power of 18. And then if you're multiplying two powers with the same base, you have to add their exponents. So 4 plus 18 is 22. So this is going to equal 2 to the power of 22. Okay, what do we have here? A bunch of different numbers. Why can't I express all of this using the same base? I can express 25 as 5 squared. I can express 625 as, 1 over 5 to the power of 4. I can express 5 as just 5 to the power of 1, and 125 I can express as 5 to the power of 3. And put all these in brackets. Okay. So if I write this as one big fraction, on the top I would have 5 squared, 5 to the power of 1, 5 to the power of 3. On the bottom I had 5 to the power of 4. So if I multiply powers with the same base at the top, I just add their exponents. So 2 plus 1 plus 3 is 6. At the bottom I have 5 to the power of 4. And if I want to simplify two powers of the same base, but they're being divided, I just subtract their exponents. So 6 minus 4 is 2. So I'm going to say that this is 5 to the power of 2. And there you go. Application problems. A farmer has a rectangular field, 3 squared times 3 cubed wide, 3 to the power of 5 times 3 to the power of 6 long. Determine the area of the field as a single power. Well, the area of a rectangular field is just its length times its width. Okay, if it helps, draw a picture. Here's a rectangular field. It has a length L, has a width W. What's the length? Well, the length is 3 to the power of 5 times 3 to the power of 6. Multiplied by its width, and the width is 3 squared times 3 cubed. And you see I'm multiplying 4 powers with the same base, so you have to add their exponents. So the result is 3 is my base. Add the exponents, 5 plus 6 plus 2 plus 3, and that's going to be 16. Now 3 to the power of 16 ends up being a big number, so just leave it like that. Okay. Part B, if the farmer creates a square field with the same area, what should the dimension of the field be? Okay, so if I have the area of 3 to the power of 16 and I want to make a square, then I should distribute the lengths of the sides evenly. I have to evenly split the exponent. Okay, so evenly split the exponent. So if I split the exponent, I can write this as 3 to the power of 8 times 3 to the power of 8. So all I do is I just say 16 divided by 2, and I make 8, right? So I make each exponent 8. So 3 to the power of 8, 3 to the power of 8. Again, if it's two powers being multiplied, you add their exponents. 8 plus 8 gives you 16. So I can make one of them the length and the other one the width. 3 to the power of 8, 3 to the power of 8. Okay.